Hello students, Strife back again. Today got practice problem 6.3, periodic trends. 13, I just want to predict which atom is larger. Our trend for being atoms is larger. We got a periodic table. When we're going down, the atoms get larger. And going across, they get smaller. Looking at your periodic table, you find magnesium and strontium. Magnesium and strontium are both in group 2. Strontium being lower in group 2, so strontium is the larger atom. B, we got SR and SN, both in period 5. SR, strontium is farther to the left in the periodic table. 10, SN, is farther to the right, meaning 10 is smaller, strontium is bigger. Okay, we got GE, SN, germanium, and 10. Germanium and 10 are both in the same group, group number 14. 10 down lower, so 10 is larger. D, we got GeBr, germanium, bromine. Germanium, bromine, both in group number, or period number 4. So we'd expect the one farther to the left to be larger, which would be germanium. And then E, CRW, chromium and tungsten, both in group 6, chromium higher up, tungsten down lower, so tungsten's going to be larger. Remember that our trend here, bigger as we go down, smaller as we go across. Bigger as we go down because we're getting to higher energy levels, smaller as we go across because you're getting more electrostatic force. Number 14, comparing elements from left to right across the period. What general trend would you predict for the energy required to remove a valence electron from an atom? And explain. So the energy should increase because as we move across the periodic table, the atoms become smaller. So the negative electrons are closer to the positive nucleus. They may have more electrons. Number 15. Predict which atom or ion is larger. Now, I'll give you each of the answers, and then I'll go back on this one and talk about a little bit of why. But A, we have magnesium. B, we have the sulfide ion. C, we have barium ion. And we have an iodide ion and a sodium ion. Yeah, with A, when you're comparing magnesium and the magnesium ion, if we get a positively charged ion, you get that positive ion. You had to remove electrons, making it smaller. B, just the opposite, we're getting a negative ion, meaning they had to gain electrons, and it's going to be larger. Now, with both C and D, they're in the same group, both ions, and in the same group they get larger as you move down. Group, larger ion. And then for E, we're in the same period, both positive, and as we move across, they get smaller. So the one just farther over here is going to be bigger, and that was sodium. 16. We want to decide whether magnesium or sulfide ion is larger, and it will be the sulfide ion. And we're supposed to explain. Magnesium had to lose 2 electrons, which ends up making it look like a neon, where sulfide ion had to gain 2 electrons, meaning it looks like a argon, and argon is bigger than neon. And within the same group, the negatively charged ions are always going to be bigger than the positively charged ions. Number 17 has the higher first ionization energy. Again, I'll go through and give you the answers, and I'll talk about this why after I get that done. So we got magnesium, oxygen, calcium, chlorine, aluminum, and bromine. Magnesium, sodium are in the same period and periodic table. As we go across for ionization energy, it gets larger as we go across. The magnesium farther to the right, larger. With sulfur and oxygen, they are in the same group. Within the same group, going down our periodic table, the ionization energy tends to get smaller. So the one higher up is going to have the higher ionization energy, so that's oxygen. Calcium and barium, also in the same group, calcium being up higher, meaning it's going to have a larger ionization energy. Chlorine and iodine, same group, halogen group, chlorine higher, up in the periodic table, iodine down lower, chlorine has the larger. Sodium and aluminum, same period, going across the period it tends to get larger, so aluminum should be bigger. And we got selenium and bromine right next to each other, both in group 4. We expect the one farther to the right to have the farther higher ionization energy, bromine. The closer they are together on the periodic table, more likely these trends might not hold. And we got number 18. We want to predict which atom forms a positive ion more easily. We got beryllium and calcium. And calcium is going to form more easily. Fluorine and iodine, it's going to be iodine. Sodium, silicon, sodium. Potassium, calcium, potassium. Strontium and antimony. Strontium, and then nitrogen arsenic will be arsenic. Now we'll go back and I'll talk a little about why on each of these. Beryllium and calcium. Calcium, which is going to form a positive ion more easily as we're moving down the periodic table. The one down lower is going to form a positive ion more easily, so it's easier. Down here at the bottom, because the atoms are bigger, meaning they are going to, the electrons are farther away from the nucleus, meaning they're going to be easier to remove, and to form a positive ion they must be removed. So calcium higher up in the periodic table, or the calcium down lower in the periodic table, is going to form more easily. Fluorine and iodine, iodine down farther is going to be easier. So both A and B dealing in the same group. C, we got sodium and silicon, both in period 3. And going across the periodic table, it's going to be easier over on this end. So easier this way, harder over here. So easier is going to be, so we've got, well, sodium and silicon. Sodium over to the left is going to be easier. Potassium and calcium. Potassium farther to the left. Strontium and antimony, both period 5. Strontium farther to the left. Easier, make positive ions. And then nitrogen and arsenic down lower, back to a period trend. It is easier. Again, this is related to the size of the atoms. Thus, larger the atom, larger atoms form positive ions. More easily. Number 19. Gaining, losing electrons, and how many. And just as I've done some number of problems on this work, I'll give you the answers, and then if you got them all right, don't need to worry about it. You can scroll on through. If you missed them, you can listen to a little explanation. So potassium's going to be lose 1. Bromine's going to want to gain 1. Oxygen's going to want to gain 2. Magnesium's going to want to lose 2. Aluminum's going to want to lose 3. Iodine's going to want to gain 1. And argon's not going to do anything. It's not going to gain or lose anything. None. Why? First thing you'll want to remember on this is that metals tend to gain, non-metals tend to lose. Potassium being a metal, it's going to lose, and if it's in group 1, it's going to lose 1. Bromine, being a nonmetal, it's going to gain, and it's a halogen in group 17, and group 17 is going to tend to gain 1. Oxygen, nonmetal, gain, group 16 for oxygen, and group 16 tends to gain 2. Magnesium, group 2, metals, and it's going to gain, it's going to lose as a metal, lose 2. And aluminum over in group 13 tends to lose 3. Iodine, another halogen, like still group 17, so it's going to gain 1. Argon is a noble gas. Noble gases neither gain or lose. Group 18 are noble gases, no ions. No gaining or losing. And number 20. What noble gas are these going to turn into? Sulfur is going to end up looking like argon. Strontium is going to look like krypton. Chlorine is going to look like argon. Beryllium is going to look like helium. Francium is going to look like radon. Nitrogen, neon, and barium, xenon. Here, the metals over on the right side or left side, as they lose electrons, they're going going to tend to go to the noble gas preceding. So metals lose electrons, and it goes to the preceding noble gas. Nonmetals tend to gain electrons, and it goes to the next noble gas. And basically, it is all, either case, it's going to go to the closest noble gas. So, look at a couple of them examples. Sulfur, non-metal, it's really close to argon. It's going to gain a couple of electrons, and it's 2 away from argon, it gains 2 electrons. Strontium, it's closest, it's a long ways away from the noble gas in its period, so you back up to the preceding period and you find krypton. And again, 2 away, it lost 2 electrons. So another way you could remember whether it's going to gain or lose electrons is how far do you have to go to get to that noble gas. Chlorine, right next to argon, so that's where it's going to go. And it's going to gain 1, move up to argon. Beryllium, closest to helium, it's going to back up 2, lose 2 electrons to go to helium. As all of these, and everything we do on here, if after my explanation on the video you still don't understand something, make sure you ask. And the highest electronegativity. So we got magnesium, aluminum, chlorine, calcium, oxygen, and bromine. Our electronegativity trend, it gets higher this way, and it gets lower this way. This is, again, just a trend. Another thing you'll want to remember, fluorine up in this corner has the highest electronegativity, and it gets lower as you move away from it. So, got magnesium and sodium. Magnesium farther to the right, and it's going to have higher electronegativity. Sodium and aluminum, both in the same period. Aluminum farther to the right, higher electronegativity. Chlorine and iodine, same group. Go down the group, you get lower electronegativity, so chlorine up higher, higher electronegativity. Another way to think about it, it's closer to fluorine. So if it's obviously closer to fluorine, it's going to have a higher electronegativity. Calcium and barium, same group, calcium up higher, higher electronegativity. Sulfur and oxygen, same group, higher up one, higher electronegativity. Selenium and bromine, same period, bromine farther to the right, higher electronegativity. And as all these are just trends, if we look at the actual values, we will find exceptions to these trends. No, that's all we have for today. Next time we'll be back with Practice Problems Chapter 6 review. That's all for now.